Hello everyone and welcome back to Exam Ignite YouTube channel. This video is all about the module 5 of the Microcontroller BEC405A subject code for the 4th semester 2022 scheme. So I'm doing this video to complete the series that I had already started on the microcontroller. So this part 1 and part 2 of the module 5 ends the series that I had started. So in this module, there are majorly five important topics that you have to know and you have to read. That is LCD, ADC, then stepper motor, DAC, and the DC motor. So you can observe here LCD interfacing. You need to know the connections as well as the ALP program. Then you need to know about the DAC. ADC, then you need to know about the DAC, that is the staircase waveform of what we'll be obtaining, then the stepper motor and the DC motor. So let's get started. In this video, I'll be explaining only LCD, ADC and DAC. In the next video, we'll go with the stepper motor and the DC motor. So this notes actually consists of everything of this module. I mean to say that the content and the program that possible questions that can be asked are mentioned in this notes. But I am going to explain you the important topics from this, and you can refer the remaining programs on your own as the comments are written and it is easy to understand. So LCD interfacing here, it is what it is used to display the numbers, characters and graphics. It is has a refreshing controller and thereby it's relieving the CPU of the task of refreshing the LCD. Easy of the programming for the characters and graphics. VCC and VSS pins are connected to +5 volts and ground. V is connected to controlling LCD contacts. So this is our LCD connection. That is, this LCD is connected to our 8051, where for the port 1 is connected to D0 to D7. Port 2 is connected to port 2 0 pin is connected to RS, 1 is connected to R by W, that is read or write, and 2 is connected to enable pin. And the VCC is connected to our +5 volts and VSS is connected to this 10K pot resistor. This actually helps us in changing the brightness of the LED. So let's get started. What are the questions that you can expect is write a neat diagram of the LCD connection to 8051 microcontroller and write an ALP to interface the LCD with the microcontroller to display the word world. So let's get started. Program. First, the common thing is that you have to write ORG000H, then move A to #38H. 38H means it is we are getting two lines in the LED with 5x7 matrix. So it is 38H. Next is A call CMD writer, that is call the command. What command? Subroutine for writing the operation. Command write, you have to call it. Next, similarly for the 38H it was that. Now next common thing is 0EH. This is what display on the display and cursor starts blinking. A call CMD writer, again call the command to subroutine. Next is 01H. This is clear the display screen. Next again call the command. Next is 06H means shift the cursor to right. Call the command again. Next 80H. This is cursor to the beginning of the first line, and let's get started. First you have to move the word W of the world. Next you have to call now. Till now we had called the command subroutine, but now we have to call here the display subroutine because W should get displayed. Now A call delay means give LCD some time to display. Next comes O R. Similarly ORLD world. So let's get displayed. Now what you have to say again, jump again means stay there itself. Now what the subroutine to send the command to the LCD, that is command writer move P1A, that is move the port 1 to the register. Move the register A to the port 1, then put clear P2.0 means RS is 0, that is to select the command register. Next P2.1 is read or write for write. Then SETB P2.2 is E1 should be 1, that is for the high pulse you have to enable. Now wait, call delay. Next again E should be 0, you have to make it low. Then return. This was about our command write. Now next write about the data write. That is what move P1, A. Move write the data to LCD. Then SETB P2.0 means RS is 1. Next R by W is 0. Now enable higher E1, E is equal to 1, that is high pulse. Now again delay and then come back to low pulse. Finally, you have to say the delay subroutine. What happens there? 50 is moved to the register R3 and 255 is moved to the register R4 in our second loop. Here means here, then again that here is moved to the DJNZ, decrement jump not equal to 0, R4. Next decrement jump not equal to 0 for the R3. Then here 2 will come, then return, and then this completes the program. ADC, analog to digital converter. Here the sensors sense the physical quantities, produce an output, that is voltage or current. We need ADC to translate the analog signals to digital numbers so that the microcontroller can read and process them. And ADC has n bit resolution where n can be 8, 10, 12 or anything. So higher resolution ADC provides a smaller step size. Conversion time is, it is defined as a time it takes the ADC to convert the analog input to a digital number. Parallel ADC means it is 8 or more pin that is dedicated to bringing out the binary data. Serial ADC only 1 pin for data out. So chip we use is ADC 0804. It is an 8-bit parallel ADC. It works with plus 5 volts and has a resolution of 8-bit. Conversion time, it is depends upon the clock pin. That is pin description, let's see. CS, chip select. Next, RD means write, RD means read, WR means write. Then click in and click R. Then INTR is our output pin and it is active low. VCC is connected to plus 5 volts. V reference by 2. D0 to D7 are the digital output pins. So this is our chip, how it looks and the connections that we have to make with this. So next go to the, what the question may be asked is you need to write a diagram or with an ALP to interface the ADC 0804 to 8051 microcontroller. So this type of question can be asked. Then here you have to interface it with this type of connection and explain them and the ALP program. So go through the program. The comments are easy so that you understand the program easily. There is also a C program where you have to write the interfacing in terms of C program. If they ask it, you have to write this. If they ask ALP, then you have to write that. Next is DAC. It is digital to analog converter. It is widely used to convert the digital pulses to analog signals. DAC resolution is a function of number of binary input and it is common ones are 8, 10, 12 bits. The number data bit input decides the resolution of DAC. That is 2 power n analog output where n is our number of data bit inputs. 8-bit input DAC provides a 2 power 8, 256 discrete voltage or current levels. So we use DAC 0808. The digital inputs are converted to current by connecting a resistor to the I out pin and then it is converted into the voltage. The total current output is a function of binary numbers. So you can get to know that this is the formula we use for calculating the I out, that is I reference of D7 by 2. D7, D6 goes on decreasing and denominator goes on increasing, that is 2 power 1, 2 square, 2 cube, 2 power 4 like that. So fine, you may ask the question like this. You have to find the maximum output obtained this type of question. Then you have to obtain the value, substitute it in the D7, D6 part and take out the value. After taking out, multiply it with the resistor, you will get the V out. So that was the about the problem. Now the type of question they ask is that you have to explain the interfacing diagram and then you have to write a program either to the staircase waveform or they may ask you for the triangular waveform also. So let's see here. This is our interfacing diagram 8051 to DAC 0808. Where then we get the output. So here the staircase waveform means if you want 5 steps, then it should be divided by 255. Why 255 divided by 5, which is 51. So you have to increment of each step is what? 51. After the maximum value is reached, the output drops to 0 and the next cycle starts. So this is the ALP program where we have to use make the switch as an input port and move the switch to the carry And then when if the S is equal to 1, what would be the case? And if S is equal to 0, what would be the case? So S is 1 means triangular routine it will jump. If it is 0, then it will go to the staircase. So this is our ALP program. We'll go through it. So this completes the part 1 video. If you want to do the sine wave, you can go through the lab program that you are having. So the stepper and the DC motor I'll be explaining in the part 2 video. Thank you for watching. Do like, share and subscribe to Exam Ignite. Thank you.